Up until this point, we've expressed most functions by just using a y. We said that y is equal to a particular expression with an x in it. And this is great when we want to emphasize that this equation actually represents a graph, because the x nicely represents the x-axis, and the y says, well, the height of this function, the position on the y-axis, is related to x in some way. However, often we don't really necessarily want to think about this thing as a graph. We want to just think about it in terms of algebra. And this y can be a little bit limiting. So often when we're dealing with a function, we will, instead of expressing it as y equals something, we express it using function notation by replacing that y with an f. So we could write this as f is equal to 2x squared plus 5x minus 3 if this was the particular function we were dealing with. Now, another curious feature of function notation is that we don't just write down that this particular equation is represented by the letter f. We actually put in brackets an x here. And this x tells us some information about the equation on the right-hand side. It tells us that in this equation, x is the variable. If I was going to plot this, the x would be what I'd put on the horizontal axis. So that's all that this little thing in brackets tells us. It tells us this is an expression, f is an expression that depends on x. Okay, so we read this whole thing here as f of x. That's what we say when we read this. We say f of x equals 2x squared plus 5x minus 3. So superficially, that's really the only difference between using a y and using function notation, this f of x. But it has a number of advantages to it. There's a lot of nice things about representing a function like this. And in the next few clips, we're going to look at what some of those reasons are.